For sure, today's technology has a profound impact on our society, on people. And here you saw another way how innovation on top of the networks, using the connectivity that's out there. And remember what I said in the beginning. Over 92% of the Earth population will have coverage in 5 years from now, and we're going to have 5 billion people having mobile broadband in 2015. That is opening a massive opportunity of doing global solution on top of those networks. Another thing that we're doing, we're looking into the future as well, trying to understand what will the networks be used for in the future. And together with MIT, we have formed a partnership in order to look at the network data today and in the future, how it will be used. Because if you think about the network, what they will use, the more we can understand as an equipment vendor, the better it's going to be for us to develop the technology that's going to support the network. How are they going to be used? We are daily running networks all around the world, knowing what's happening. But with the partnership with MIT, we're looking at them from the human level on a much higher aggregation level. And here today, together with me, I will have the Professor Carlo Ratti, which is the director for the Sensible City Lab at MIT, that will tell us a little bit more about it. So please welcome Mr. Carlo Ratti. Hello, Carlo. Tell us a little bit about our partnership and how we're going to analyze all the data.
Thank you, Hans. It's a great pleasure to be here. Thank you for the invitation. Yes, we're delighted and thrilled about this new partnership with Ericsson, because really the network can help us support many of the activities that we will do tomorrow. And let me show you something based on the work we do at our lab. It's a Sensible City Lab at MIT. Now, I want to start with this picture. I'm Italian. Everybody in Italy grows with a picture like this in their bedroom. But the reason I'm showing you this is actually that something very interesting happened in Formula One over the past 15 to 20 years. Now, 20 years ago, if you wanted to win a Formula One race, you take a budget, a good budget, and you bet it on a good car and a good driver. And if the car and the driver were good enough, then you'll win the race. Now, today, however, if you want to win the race, you need something like this. This system is a system with thousands and thousands of sensors onto the car, collecting information in real time, sending information to those computers, and then analyzing, processing, making decisions in real time in order to win the race. All of that is happening through the wireless network. In other terms, as engineers, we call this a real-time control system. It's a system that basically made of two components, a sensing component and an actuating component. That's really what we all do in our everyday life. When we meet each other, we sense each other, we collect information about us, and then we respond to that. It's every dynamical human system really behaves in this way. Well, the amazing thing we believe today is that actually our environment is starting to behave like a real-time control systems. Over the past 10, 20 years, we've blanketed our cities, our buildings, our whole environment with all of these digital layers you see here, and that's radically changing the interaction we have with it. It's the digital and the physical, it's bits and atoms coming together, and we are in the middle. And in other terms, you can think about it almost as if you were taking every atom out there of the physical world, and every atom was becoming both a sensor and an actuator. And of course, the network is central to all of this. The network is really the connection between those two layers. And I just want to share with you a few of the projects we've been doing, and also some of the things that we're planning to do with Ericsson. Well, the first thing I want to share with you is a project we recently did. It's called Trash Track, and it starts from a very precise question. Today, we know where objects come from, but we don't know where they go. When we throw them away, we know very little about them. And what you see here is a picture. You see that computer. Well, every chip on that computer, as you see here, you can trace it, you know, where it was produced, how it moved across the globe, how it became that machine, how it came to your desk. However, a few years from now, when you throw it away, you know very little about it. So what we decided to do was actually to put little tags onto trash and start following trash around and see where it ends up. every type of trash. What you see here is actually the deployment with a number of volunteers. The first deployment we did, try to tag many, many different pieces of trash, anything from a banana peel to a toy to electronics, e-waste, the big problem today. And then following the tagging, we started tracking trash. So what you see here is 3,000 tags from Seattle, deployed in Seattle, the day of deployment, how they start to move after a few days, 7 days. Some of them, many of them, went to the main dumps next to Seattle. But then after 2 weeks or 3 weeks, still a lot of things moving. A lot of things moving in a very chaotic way. You see left and right, east and west, and going back west. And then still after a month. It's very interesting because everybody knows a little bit of the chain, but nobody had traced all of it till now. And still 2 months, something moving. We thought the Firewall Symphony was what we needed as music. Well, we're still working on this. We're actually working on tracking and tracing many other types of waste. We're doing a lot of work on e-waste. Some of this was actually presented at MoMA, the Museum of Modern Art, last summer in New York, as part of an exhibition called Talk to Me, really about our environment starting to, through the network, starting to talk back to us, to become like alive. And I wanted to show you something then very funny that happened just a few weeks ago. And that's the first time I'm showing it, following the MoMA show. Look at this. All right. Well, very briefly, we saw now how the network really enables a whole new layer and type of interaction between our objects. But really, beyond objects, that's really about all of us. It's about people. And here I want to show you this. In this example, for instance, we looked at the United States. We looked at how we can take data from the network and use it in order to understand communities and kind of redraw the map of the United States. It's a map of the United States that's drawn not because of political boundaries, not because of historical boundaries, but really because of how we as humans talk and communicate with each other. You know, we all know this map, but then when you take the network and use the data of it and put it on the top of it, then you can use it in order to redefine almost the geography of the place. Some states merge, some split, is what you see in a moment. And it's almost like, it's what we call the connected states of America. Really kind of bottom-up geography. And of course, you can zoom in into a city. That's something we're doing in Singapore. And you can zoom in a much finer grain level and look at what happens there. Again, thanks to the real-time information that's collected, provided by all of these mobile networks. And imagine a living city where you know in real time all what's happening around yourself. That's a very tough thing in Singapore, get a taxi when it rains. And usually it rains in patches. So actually if you take the information of the rain in real time and the taxis, you can make a much better match between the two. You can look at the information about the island and the traffic, how it expands and shrinks based on time and usage. And then really all of the global flows as well, all of the flows we saw before about shipping containers, people moving in and out, you can really look at that with the idea that we collect all this data in Singapore and we make it free accessible to everybody. It's almost like open data, but not open data of recorded data, but real-time open data. And as a final thing, what I wanted to start sharing with you is, as I mentioned, we are thrilled about this new collaboration with Ericsson, really using the data to learn a lot about society and about ourselves. We just started a few weeks ago, but I just want to show you just a little bit of the initial analysis we did to show you the power that you have when you look at the network and you try to understand, use those data to better understand us. And so what you see here is actually that's a few milliseconds of the network. There are some visualizations done by Pedro Cruz in our lab, a Sensibility lab. You see it's a change in logarithmic scale, so dynamically it's going faster, a few milliseconds, but there you have a whole day. You see the night and the day, the 12 hours. And then if you look at this, it's a total traffic on one network in Europe. But then you can look at it in more detail and you can see the different type of activities supported by that network. You see here you got people using it for web browsing, for email, for downloading videos, for all those other activities that you see there. Well, that's for one network, but you see how it accumulates from little time to the whole week. And then if you sum several networks, what you see here is from the top to bottom, you see Asia, America, and Europe. And you see how that changes, that activities. What we do with the network actually changes based on time and based on the place, on where we are. And that's what you see here. Again, the microsecond at this scale in the whole week. And when you combine it all together, you get this very interesting signature. It's very constant. It's almost like the pulse of all of us using the network on the whole planet, almost the pulse of the planet. Call it, I don't know, we said, the signature of humanity, of all of us using this in order really to support what we do in our everyday life. And what we really want to do over the next few months and years is really use this data to better understand society and ourselves. Thank you.
Thank you. It's exciting to see what the network is evolving during day and nighttime, different regions and the content of it. And I think we're probably going to see a lot of change in the usage of the network over time, and we're going to continue to follow them.
Yeah, absolutely. So I'm sure that in five years from now, if we were to look at this, we'll see a very different graph. But the important thing is that that graph will tell us something very different about ourselves.
Yes. About the humanity, how we use the networks. Thank you very much, Carlo.
Thanks again.
Thank you very much. A big hand of applause for Carlo.